Today let us move on to page number 146 and 147. We have been discussing about pressure and solid pressure and pressure exerted by the liquid. What do you know about pressure exerted by the liquid? A liquid exerts pressure in all the directions. The greater the height, the greater the pressure exerted by the liquid, and the greater the density and greater the pressure exerted by the liquid. These all things we have discussed with the help of activities. All the liquids exert upward force, that is upward pressure. The tendency of the liquid to exert upward force is called buoyancy force. The upward force is called buoyancy force. It is also known as upthrust. How we will measure the pressure of the liquid? It is an instrument called manometer. Manometer is a device which is used to measure liquid pressure. The manometer is made of U-shaped glass tube which is fitted to the wooden block, that means wooden board. U-tube is filled with colored water. That water should be half filled to its limbs. It has two limbs, both the limbs should be half filled with water. The one end of the U-tube is opened, the other end is fixed to the rubber tube which is connected to the pistol funnel. This is a setup of making manometer. A scale is also fixed to the wooden board. Now we have to cover the mouth of the pistol funnel with the help of rubber sheath. So what do you understand? The funnel, opening end of the funnel is covered with one rubber sheet. Now what you're going to do is, if you press this rubber sheet, what will happen to, the pressure will be exerted on the air, which in turn pressures the water level in the limb A, and this water will go down in limb A, whereas in limb B, the water will rises up. You can read the difference in water level on the scale. This is a measure of pressure exerted by the rubber sheet. Now you are going to find the pressure of liquid. What do? Dip the funnel of this manometer in the water containing in a beaker. You can observe that the level of the water in the limb B rises up, whereas level of the water in limb A falls down. What is the reason? When you put this funnel of a manometer in water, the liquid exerts pressure upwards. This pressure pushes the air which is present inside the tube, which in turn pushes the liquid in the limb A, and this liquid falls down, and at the same time the level of the water in limb B rises up. Now you have to find the difference between both the water level in limb A and B. This difference gives the pressure of the liquid at that depth. Now don't change the position of the funnel which is inside the water. Just change the direction of the funnel from that position. You will see the same reading. And in other opposite direction, now you are going to turn the funnel from the same height. What do you observe? There is no change in pressure level. This shows that liquid exert equal pressure in all the directions. But if you change the funnel from the fixed position, that means funnel was kept in the particular point in water. If you change the funnel, if you move the funnel just below that particular point or above that particular point, definitely the reading will be changed. Definitely the level of water in both the limbs might be changed. But if you keep at the same point and change the direction of the funnel, the reading remains same. This shows that the liquid exerts equal pressure in all the direction from the particular place. But you change this funnel from that fixed position, the reading may be changed, which senses that different height, it shows different pressure by the liquid. You might have noticed the base of the dam is broad. It is broadened at the base than at the top. This is because when you move down inside the water, with greater depth from top, the pressure will be increased, the pressure of the liquid increase. We can say that with increase in depth, the pressure of the liquid will be increased too high. This is the reason the base of the dam is made broad in order to withstand the high pressure exerted by the liquid. Now let us move on to the activity 6 to prove that pressure increases with the depth. Here materials required are a transparent plastic tube, water, ink, a glass beaker, sellotape. Take some water in a bowl and add a few drops of ink in it. Now make the shape of transparent plastic tube in the form of U. Put some colored water in the tube into the length of about 8 cm. Now we are going to paste this U tube to the square piece of white chart paper with the help of sellotape. Now U-shaped plastic tube is ready. Make sure that the level of water in both arms remains same. Now you are going to put the end of the long tube in a beaker filled with water. Due to the pressure of the water, we can see the changes in water level in both the arms. You know that over the water level in the U-tube, air particles are present. When you put this end of the tube into the water, because of pressure of water, the air which is present inside the tube pushes the liquid downwards, and at the same time the level of water in other arm rises up. Before putting this tube into the water, the level of the water remains same. When you started dipping this tube, one end of the tube into the water, the difference of the water level varies according to the depth of the water. If you put a tube in the top level of the water, you can see small variation in the water level in both the limbs. But if you put the same tube inside the water, deep into the water, you can see much difference of water level in both the limb. This gives the different pressure exerted by different liquid. This liquid pressure increases with depth. Find out the difference in water level between these two arms. This will gives the pressure exerted by the liquid. Now let's move on to next topic, consequences of liquid pressure. Sea divers, they use special suits when they dive into the sea water. What is the reason? The pressure exerted by the water in the ocean increases with the depth. When you go down into the water, the pressure of the liquid, pressure of the sea water will be more. So it would crush us into pieces. So in order to withstand this heavy pressure, this high pressure by the sea water, they will wear this special suit in order to protect them from this. So when you go down into the water with increase in depth, pressure will be more. We cannot swim, we cannot survive with the deep inside the water because pressure will be more in this area. So we cannot survive under this high pressure. In the same way, if you bring sea fishes from deep inside the sea to the surface of the sea, what will happen? They will burst, their body will be burst. Why? Because when they are living deep into the sea, their body pressure and fluid seawater pressure remains same. When you bring this fish up, what will happen? The top area, I told you, the surface of the water pressure will be less, liquid pressure will be less. So inside of their body pressure is more than the water, so it will burst because pressure of this body is more than pressure of liquid at the surface of the seawater. The other example is submarines. They used to wear hard, thick sheet of metal to withstand the high pressure by the seawater under sea.